Hi everyone. So here is a project synthetic multilingual instruction generation. So coming to the problem statement, like our primary motivation for this project was, to address the lack of high quality instruction data for low resource languages. And most instruction data sets are actually focused on more popular languages. And also for the case of like low resource languages, there are things like website licensing, which limits scraping as an option. For example, for IO 101, we tried it with an Indic language, and after going ahead with 250 after we checked like 250 different data sets, 250 different websites, we were only able to find 5 to 6 different websites which are like non-licensed, and we were able to scrape them, but it's very difficult. And as previous research has shown, we require such datasets, instruction datasets, to boost the performance of the model on downstream tasks in the respective languages. And therefore, to address this, we wanted to create a scalable methodology for generating non-licensed synthetic multilingual instruction dataset, which can help community and also the companies. And the approach we broadly use like three different approaches, which utilized various techniques, including context-based generation, distillation, and translation, amongst others. We'll be covering these approaches.
Please.
It's the next slide. Yeah.
No worries.
Sorry. Uh, we broadly use like three different approaches which utilized various techniques, including context-based generation, distillation, and translation, amongst others. We'll be covering these approaches in detail in the next coming slides. But for our POC, we primarily went with Hindi, but our approaches scale irrespective. I mean, scale very easily for other languages as well. We've primarily utilized Llama because of the non-licensed generations and also its state-of-the-art performance. And coming to the next slide. Uh, Coming to a first approach, which is the Orca approach, we leverage the Orca dataset, which is an extension of the FLAN dataset. But as part of the Orca, what do they do is they include like more descriptive prompts, such as think step by step, or think before you speak, or give the explanation before you give the answer. This helps actually get the longer outputs. But the problem with this is that the responses are actually like generated from GPT-4, making it like a licensed dataset. We replaced it with Llama 3.1 70 billion model to generate the responses, thus making it like a non-licensed dataset. Uh, so once we get this distilled dataset from Llama, we further filter out the data which is uh, which might not be very relevant for translation to downstream tasks. So from that we get like close to like 100,000 English only like dataset. The advantage of this is that we can use this to translate it into any language you want. And in our case, we translated into Hindi, and we got the Hindi dataset. And yeah, I think the next slide, I think Roshan can take it.
Yeah. For the second approach, we use the Hindi Wikipedia corpus to extract paragraphs that are then passed as context to Llama to generate question answer pairs. With the initial generations, we observed that the answers tended to be shorter and not as descriptive. Therefore, to address this, we gave the generated questions again to Llama to generate longer, more descriptive responses. We further manipulate the generated context question answer pairs to come up with new types of instructions. And this basically helps us create a larger, more diverse instruction data set. Next slide. For our final approach, we utilize two versions of the FLAN dataset, the original version along with the chain of thought variation. These samples were then translated to Hindi using the Llama model. The key modifications that we performed included filtering the longer outputs and also resampling the dataset to maintain an even distribution amongst the different task types. Next slide. All right. So at the end of all of this, we have created around 250,000 instructions with 130,000 in Hindi and the remaining in English. And the table below gives a very high-level overview of the data sets that are being generated by each approach. Next slide.
Uh,
This,
yeah,
yeah.
so, yeah. So at the end of like the 6 weeks, we are able to like present a dataset that stands out as being one of the largest and most diverse Hindi datasets. And all of our datasets are non-licensed and can be used for both like commercial and non-commercial purposes. And in terms of the limitations, we realized that certain subsets of our datasets might be helpful more for small language models rather than LLMs, because we rely on the LLM output generation itself. And to address this, we're planning a self-instructive. And additionally, limitations include the availability of like non-licensed corpora and existing LLMs translation capability to like very low resource languages, and also ultimately like we might need some GP credits for running Llama. So the next slide, regarding the future work, like we are currently like fine tuning models on our data sets, and we're planning to benchmark it. This should be done like within 1 to 1.5 weeks, and we're also like expanding into other languages. For example, like Pashto language, we are thinking of also like introducing new question types for context tasks such as MCQs, fill in blanks, true or false, etc. We also plan to like make a Hugging Face submission on our Orca-based dataset to see its accuracy. We also like plan to discuss with like Indian startups who are working on like multilingual SLMs on utilizing our dataset. There are a few such startups, and so yeah, we have added our dataset samples, the prompts, and the data transformation which we did in the appendix for everyone's reference. So yeah, that's it with our